is AP Calculus, section 2.1, page 8, limits of the trigonometric functions. When we do limits of the trig functions, we start just like we do with all of the other limits by substituting in. So we'll find the limit as x approaches pi over 6 of sine x is going to be sine of pi over 6. And the sine of pi over 6 is a half. Pi over 6, first quadrant, bottom one, sine y coordinate there, that is a half. When we look at the next one, the tangent x, and we want the limit as x approaches 2 pi over 3, so we need the tangent of 2 pi over 3. 2 pi over 3, second quadrant, top one up here. Sine there is square root 3 over 2 over negative half for cosine. That gives us negative square root 3. There's that one. When we look at the limit as x approaches 0 of sine x over x, for this one, when we substitute in, we get the sine of 0 divided by 0, which is 0 over 0, and we have a problem. So we can't factor, we can't rationalize the numerator or denominator, so we're going to need to graph this. So grab your calculator, please, and let's put this in. Make sure your calculator is in radians and set the window to be -5 to 5 in the x's, -5 to 5 in the y's, and we graph. We see something like this. And with our window, it appears that the limit is 1. If we kind of go through and just verify that, if we do a value at x is 0, we see that there is no y coordinate here at all, which makes sense. There isn't anything there. But now hit trace and arrow to the right, and we can see as x is getting closer to 0 from the right-hand side, the y values getting closer to 1. As a matter of fact, at 0.07 for x, y is 0.999. If we go on the other side, we will see the same thing. Moving closer to x is 0 from the right-hand side, y values are approaching 1. This is a limit that you need to memorize. If we look at the reciprocal of that function, same viewing window, same idea here, looking as x gets close to 0, y values look like they're getting close to 1. Let's check. Yeah, nothing there at x is 0, which we know already. Oops, forgot to hit trace. Hit trace and follow along. And oh yeah, definitely, when x is 0.07, y is 1.000. So absolutely that limit is 1. And you need to memorize that one as well. I forgot to talk about subbing in. We should have substituted the 0 in first. And then that's why we went to the calculator. Looking at this next one down here, the limit as x approaches 0 of 1 minus cosine x over x. If we sub in the 0, cosine of 0 is 1, so we have 1 minus 1 over 0, or 0 over 0. More problems. Can't factor, can't rationalize, so let's go ahead and take a look at a graph. And you should see that this limit is 0. It does hit right here, very close to 0, 0. So here's another one that I'm going to ask you to memorize. And this last one as well, I will ask you to memorize this. Go ahead and start graphing that on your calculator. And let's see what that limit is. And here's x equals 0, and we see that this limit does not exist. From the left-hand side, the y values are going down here toward negative infinity. From the right-hand side, y value is going up toward positive infinity. Different directions, therefore that limit does not exist. That's it for the calculator, so we'll put that away. When we look at this next one here, we have an issue because of this 2 right here, but we remember our pre-calculus, and we can rewrite that as 2 sine x cosine x all over x. And then we know we can separate this limit over the product, so let me separate this as the limit as x approaches 0 of 2 times the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of cosine x. And to verify in your mind that that is the same thing when we multiply, let me cover up all these limit pieces here. And can you see 2 times sine x over x times this cosine x over here? That will give us exactly what we started with. Evaluating these limits now. The limit as x approaches 0 of 2 is 2. This limit as x approaches 0 of sine x over x, that's 1. Just memorize that right up here. And this one, the limit as x approaches 0 of cosine x, when you put the 0 in there, it's cosine of 0, which is 1. We have 2 times 1, which is 2. Looking at this next one, we don't have a nice identity for the sine of 4x. So what we can do is we have to do some other algebraic manipulation. Looking at this fraction right here, we're going to multiply by 4x over 4x. And that is legal to take a fraction and multiply the numerator and denominator by the same thing. Then let's just do some algebraic manipulation and rewrite this as sine 4x over 4x times 4x over 7x. If that bothers you, just look back. If you multiply across the numerator down here, you'll get the same thing as you do up there. And multiply the denominator down here. That's the same thing as we did up here. Now let's separate that limit over that product. So the limit as x approaches 0, sine 4x over 4x times the limit as x approaches 0 of, well, 4x over 7x simplifies to be 4/7. And while we're here, we might as well do this limit of that constant. That is just 4/7. Over here, we have a little bit of an issue because these don't match. This x, this 4x, and this 4x. So we have to kind of think about this and realize that if x goes to 0, 4x also goes to 0. So to get from here to here, what we said is if x goes to 0, then 4x also goes to 0. So we can change that. Now, this statement right here looks exactly like that one, all the way up here in number 17. The only difference is, instead of writing an x, we've written a 4x. It's exactly the same limit. This limit is 1 times 4/7. 4/7. All right, now some of you may have noticed, looking back at these last two problems, if you look at the original problem and the final answer, I don't know how to cover all this up. Original problem, final answer, original problem, final answer. Notice what we did essentially is we had fraction of the leading coefficients. So 4/7, 2 over 1, 2. Works every time, but just for signs. It also works here if we have sine 3x over sine 5x. It doesn't have to be a sine and a plain old x, a sine and a plain old x. It could be a combination of signs. This limit is just those fraction of coefficients is 3/5. If you would like to see the algebra on that, please ask your teacher, and he or she will be very happy to show you the algebra to prove up why that's 3/5. But for our purposes today, moving on, let's look at this one. The limit as x approaches 0 of x plus sine x over x. First thing, always substitute in. This gives us 0 plus the sine of 0, 0 over 0. So now we can do some of our other manipulation here. Could we separate this and write this as x over x plus sine x over x? Sure we can. Then we can separate over this addition sign. And we have the limit as x approaches 0 of a 1 plus the limit as x approaches 0 of sine x over x. We have 1 plus 1, which is 2. And there we go. Looking at this guy down here, we do have a cosine in here, but we also have a sine, so we have a little bit of an issue. What we're going to have to do is to replace out that cosine 2x. And you remember we have 3 possibilities for this cosine of 2x. We have 2 cosine squared minus 1, 1 minus 2 sine squared, or cosine squared minus sine squared. All right, I'm going to choose the one that's going to get rid of that 1 right here. So let's do the limit as x approaches 0. Let's see, that would be 1 minus, we're going to have to choose this middle one. 1 minus, uh-oh. I think I said this over here, but I didn't write it. It should have been 2 cosine squared theta minus 1, and this should have been 1 minus 2 sine squared. I'm so sorry. Okay, distributing that minus sign through, we will have the limit as x approaches 0, 1 minus 1 gone, minus a minus 2, that's 2 sine squared, oops, and I goofed here, there should be an x, sorry, 2 sine squared x over sine 3x. Now let's separate it and do the limit as x approaches 0 of 2 times sine x over sine 3x times another sine x over a 1. You just want to go back through and make sure that this multiplies together to give you what you started with. Limit of this first piece is 2. Limit of this second piece, fraction of those coefficients on x, so 1/3 times limit of sine over 1, that's 0. Plug in the 0. Sine of 0 is 0. So this limit is 0. Last one. Oh boy. 1 minus cosine squared of a half x all over a 3x squared. It's kind of ugly, but do you see this 1 minus cosine squared theta? That's sine squared theta, which is half x. All over a 3x squared. Now let's separate this. And let's think of this as 1/3 times sine of a half x over x times sine half x over x. And now find these individual limits. Limit of 1/3 is 1/3. The limit of this one, sine half x over x, that's half. And the limit as x approaches 0, same thing over here, half. And we get 1/12. Okay, thank you very much for joining me on limits of trig functions. The next page, we do the squeeze theorem.